All right, we're in section 7.2 where we are going to use the converse of the Pythagorean theorem. So from the previous section, we were able to use the Pythagorean theorem, a squared plus b squared equals c squared, to figure out any unknown side lengths to a right triangle. Okay, we're going to apply that theorem for different exercises today. One of the things that we're trying to identify if a particular triangle is in fact a right triangle. If a triangle is given all three of the sides and it satisfies the Pythagorean theorem formula, then we can say that that triangle is in fact a right triangle. That's what the converse of the Pythagorean theorem is stating. Okay, so what we need to do with these examples here is we need to determine if these triangles are in fact right triangles. Okay, so what we need to do is the first thing you have to identify is what is the largest value. So sometimes it's a little bit more tricky to figure that out, especially when there's a radical involved. So if you look at, uh, we got 9, we got 15. If you were to give an approximation of the square root of 34, that's about 5.83, but you multiply that by 3, and you get something like 17.49. So 17.49 is larger than 15, so this is going to be my value of C. So I want to see if 9 squared plus 15 squared is going to equal 3 times it by the square root of 34 squared. So 9 squared is 81, plus 15 squared is 225, and I want to see if it equals 3 times by the square root of 34 squared. Well, how we're going to do that is you have to use the power of power rule, and you're going to have to attach that square to both the 3 and the square root of 34. So square root of 34 squared is just 34. 3 squared is 9, and 34 times 9 gives us 306. So all we got to do now is take 81, add to 225, and that does in fact give us 306. So 306 equals 306. So we can say yes, this is measurements for a right triangle. Okay. For example B, it's a little easier since they're all integers. The largest value here is 26. That's going to be my value of C. So now I have to determine if 14 squared plus 22 squared is going to equal 26 squared. 14 squared is 196 plus 22 squared is 484, and 26 squared gives us 676. So I take 196 plus 484, I get 680. 680 does not equal 676, so no, not a right triangle. Sometimes they will just give us um, measurements without giving any drawing itself. If you want to make a drawing, that's up to you. Most of the time, you just got to figure out what is the largest value. Again, I got that 4 times the square root of 3. Square root of 3 gives you 1.73. And you multiply that by 4. That gives you 6.92. So that's not the largest one. The largest one in this case is 8. So we're going to say is 4 squared plus 4 times the square root of 3 squared. Is that going to equal 8 squared? So 4 squared is 16. And square root of 3 squared is 3. 4 squared is 16. So 16 times 3 is 48. and I want to see if that equals 8 squared, which is 64. So taking 16 plus 48, I got 64. 64 equals 64. I can say yes, these make up a right triangle. 10, 11, 14. 14 is my largest value. I got 10 squared plus 11 squared. I got to see if that equals 14 squared. 10 squared is 100. 11 squared is 121. And 14 squared is 196. 100 plus 121 is equal to 221. That does not equal 196. So no right triangle here. All right, last one on this page is E. I got square root of 61. That gives me approximately 7.81. So that's my largest value. So I want to see if 5 squared plus 6 squared is going to equal the square root of 61 squared. 5 squared is 25 plus 6 squared is 36. And the square root of 61 squared is just 61. 25 plus 36 is 61, so 61 does equal 61. So yes, we have a right triangle. Other part of this lesson where we're going to kind of use the Pythagorean Theorem per se to kind of help us out in classifying uh, triangles by their angles, and also be able to figure them out using side measurements. So if you look here, we're going to try to determine whether a triangle is a right triangle, an acute triangle, or obtuse triangle from these side measurements. So we have an acute triangle right here. We have a right triangle right here, which will illustrate it, and we have an obtuse triangle right here. Okay, by definition, acute triangles have 3 interior angles that are all less than 90. We have a right triangle, we all know, is we have one side length that is exactly 90 degrees, and an obtuse triangle, we have one side length that is greater than 90 degrees. Okay, so there is a theorem that is going to allow us to determine if a triangle is acute, right, or obtuse by their side measurements. So we know how to determine if a triangle is a right triangle. We use the Pythagorean theorem. A squared plus b squared is going to equal c squared. All right, we use that one all the time. We are also going to use a squared plus b squared and c squared for both obtuse and acute triangles, but we're not going to use the equal sign now. We are going to use an inequality. So when the side lengths are going to make up an acute triangle, a squared plus b squared will actually be larger than c squared. When you look at an obtuse triangle, a squared plus b squared will actually be less than c squared. Okay, so what we're going to do is, with these examples, we are going to take a squared, add it to b squared, and we're going to take c squared. Now, just like when we use the Pythagorean theorem, this value here is going to be my largest value. Okay, so you got to determine which one's the largest value between the 3, and then go with that. Once you figure out what that is, you bring it down to the last result, adding up the sums of the squares of a and b. You take the square of c. If they're equal, it's a right angle. If the sums of a and b squared are larger than c, it's an acute. If a squared plus b squared is smaller than c squared, then it's an obtuse. Okay, so that's how we're going to go with that. So looking at the first one, I got 4.3, 5.2, and 6.1. My largest one is 6.1, so I got 4.3 squared plus 5.2 squared, and I got 6.1 squared. All right, I'm not writing an equal sign or any of the inequalities yet. I want to solve it out to see which one it is. So 4.3 squared gives me 18.49 plus 5.2 squared gives me 27.04. And then finally 6.1 squared is 37.21. So I take 18.49 plus 27.04 and I get 45.53. That is larger than 37.21. So the sums of A and B, their squares, is larger than C squared. So this is an acute triangle. All right. Example B, I got 11, 23, and 20. 23 is my largest value, so I can say 11 squared plus 20 squared, and then I got this 23 squared. I kind of put it off this side. So 11 squared is 121. 20 squared is 400. So that gets added. And then finally 23 squared is 529. So 121 plus 400 gives me 521. That is less than 529. We have an obtuse triangle. All right, so square root of 41 times that by 2, that gives me 12.8. That is larger than 8 or 10, so that's going to be my value of C. So I can say that, 10 squared plus 8 squared, and then I want to see if it's 2 times the square root of 41 quantity squared. So 10 squared is 100 plus 8 squared, which is 64. And then square root of 41 squared is 41. Times that by 2 squared, which is 4. So now I got 164. All right, 100 plus 64 is 164. That's going to equal 164. Since they equal each other, we have a right triangle. And then last example here, we have 11.2, 6.5, and 7.1. 11.2 is my largest value. So I say 6.5 squared plus 7.1 squared, and I got the 11.2 squared. 6.5 squared gives me 42.25 plus 7.1 squared is equal to 50.41. And I got 11.2 squared gives me 125.44. So 42.25 plus 50.41 gives me 92.66. That is less than 125.44. So we have an obtuse triangle. Okay. And that is how we apply the converse of the Pythagorean theorem. Hope this helps. Until next time.